Okay, so this is the review for test number 11. So number 1 is to solve the system of equations using elimination. Okay, so I have 3 equations with 3 unknowns. So I first labeled the equations here, equation 1, 2, and 3. So I'm going to start with equation 1 and 2, and then I'm going to go to equation 1 and 3, and I'm going to eliminate the same variable. So I'm going to just right now rewrite equation 1. So that's negative x plus 5y plus z equals negative 9. And equation 2 is negative 6x minus 3y plus 4z equals negative 21. All right, so what I'm going to do, and also what you should do before you even start this, is to write down what your solution was, so plug it into your calculator to get the with the matrix. So the solution is 4, negative 1, 0. Okay, so what I'm going to do is I'm going to get rid of the x's here. So I'm going to multiply the top equation by negative 6 so that I get a positive 6x here. So I get positive 6x minus 30y sorry, that's minus 30y, minus 6z, and that equals positive 54. And then I'm going to leave the bottom one the same, so that's negative 6x minus 3y plus 4z equals negative 21. Okay, so I add them together, and I get the x's to cancel, so I get negative 33y minus 2z equals 33. I'm going to call that equation A. And now I'm going to take equation 1 and 3. So here's 1. So that's negative x plus 5y plus z equals negative 9. And equation 3 is negative 2x plus 2y minus 4z equals negative 10. So I have to get rid of the x's here, same thing as the top. So I'm going to multiply by negative 2. So when I multiply by negative 2, I get positive 2x minus 10y minus 2z equals positive 18. I'm going to keep the bottom equation the same, negative 2x plus 2y minus 4z equals negative 10. And together the x's cancel, so I get negative 8y minus 6z equals positive 8. And this is going to be equation B. So now I'm going to take equation A and B and put them together and solve them. Okay, so A is negative 33y minus 2z equals 33. And equation B is negative 8y minus 6z equals 8. Okay, so what I'm going to do is I'm going to multiply the top equation, equation A, by negative 3, so I can cancel out the z's. So I have positive 99y plus 6z equals negative 99. And I'm going to keep equation B the same. So it's negative 8y minus 6z equals 8. So add them together, I get 91y. 6z and negative 6z cancel equals negative 91. Divide both sides by 91. And we get y is equal to negative 1. All right, so let's find the z value. In order to find the z value, I have to plug it into either A or I have to plug it into B. So what I'm going to do is I'm going to plug it into B. All right, so B is negative 8y minus 6z equals 8, and I'm plugging in y is equal to negative 1. All right, so I have negative 8 times negative 1 minus 6z equals 8. So negative 8 times negative 1 is 8 minus 6z equals 8. Minus 8 from both sides, I get 0. Divide by negative 6, z is equal to 0. So now let's get the x value. So I have to plug in one of the originals. So I'm going to plug it into negative x plus 5y plus z equals negative 9. So negative x plus 5 times 5 times 1, negative 1, plus 0 equals negative 9. Negative x minus 5 equals negative 9. Negative x is equal to, add 5 to both sides, negative 4. So positive x is equal to positive 4. Okay, so let's take a look at 1b. Okay, so the same thing as before, I'm going to take 1 and 2 and put them together. So I have 1 is 3x plus 4y plus 3z equals 1. And I have 2 is negative 3x plus 3y plus 5z equals 30. So this is already set up nicely to actually get rid of the x's. So 3x minus 3x is 0. 4y plus 3y is 7y. 3z plus 5z is 8z is equal to 31. All right, so now I'm going to take 1 and 3. So we call that a, sorry. All right, so 1 is 3x plus 4y plus 3z equals 1. And 3 is negative 2x minus y minus 4z equals negative 5. Okay, so I'm going to have to get rid of the x's. So I'm going to have to multiply the top one by 2 to make it 6x and the bottom one by 3 to make it negative 6x. All right, so I get 6x. So 6x plus 8y plus 6z equals 2. And negative 6x minus 3y minus 12z equals negative 15. Sorry. Okay, so the x's cancel, so I get 5y minus 6z equals negative 13. All right, and that's equation B. All right, so now I'm going to take A and B and put them together. So A, 7y plus 8z equals 31. B, 5y minus 6z equals negative 13. Okay, so now I'm going to multiply the top equation by 3 and the bottom equation by 4 so that I can eliminate the z's. All right, so I'm going to multiply the top by 3 and the bottom by 4. So I'm going to get 21y plus 24z equals 93. And the bottom one by 4 is 20y minus 24z equals negative 52. Okay, so we're going to add them together. So we have here 41y, the z's cancel, equals 41. Divide both sides by 41, and we get 1. Okay, so now I'm going to take y equals 1 and plug it into 7y plus 8z equals 31. So 7 times 1 plus 8z equals 31. So minus 7 from both sides, 8z is equal to 24. So z is equal to 3. And now I'm going to take that, the z and the y, and plug it into one of my originals. I'm going to plug it into 3x plus 4y plus 3z equals 1. So it's 3x plus 4 times 1 plus 3 times 3 equals 1. So 9 plus 4 is 13. So it's 3x plus 13 equals 1. Minus 13 from both sides, we get negative 12. So divide by 3, we get x is equal to negative 4. Okay, so let's take a look at 2. Okay, so this is the partial fraction. So the first thing I'm going to do is factor the denominator. So the denominator factors, and that becomes x minus 5 and x plus 2. All All right, so this is going to be equal to an x minus 5 here, and then x plus 2. It doesn't matter which one you put first. I'm going to put a above the x minus 5 and b above the x plus 2. If you have them switched around, that's fine. All right, so I need to get the same denominator, so I multiply this one by x plus 2, numerator and denominator. And this one by x minus 5. All right, so now that I have the same denominators, right, I'm really just worried about the numerators now, so I could get rid of that. So I know 7x plus 7 has to equal, distribute the ax plus 2a equal, plus bx minus 5b. So my x's, so 7x has to equal ax plus bx, and 7 has to equal 2a minus 5b. All right, so for the x's, I just have to make sure my a plus b equals 7, so 7 equals a plus b. The bottom equation right now I'm just going to leave the same, so I have 7 is equal to 2a minus 5b. There's no x's to get rid of. So I want to eliminate one of the variables. So what I'm going to eliminate is the b. So I'm going to multiply by 5. So I get 35 equals 5a plus 5b. The bottom one I'm going to keep the same. So 7 is equal to 2a minus 5b. So the b's cancel, so 35 plus 37 is 42, equals 7a. Divide by 7, a is equal to 6. So now what I'm going to do is I'm going to take this equation here, 7 equals a plus b, plug in a is 7, a is 6, and solve for b. So b is equal to 1. Just make sure you write your final answer, your partial fraction. So it's a over, so that's 6 over x minus 5 plus your b, which is 1 over x plus 2. Okay, so let's take a look at 2b. So the same thing again, we're going to factor the denominators. The denominators factor, and they become x plus 2, x minus 1. All right, so it's going to be a over x plus 2 plus b over x minus 1. All right, so I'm going to multiply the left fraction by x minus 1. And the right fraction I'm going to multiply by x plus 2. Okay, so I'm going to cross off the denominators, and this is what I'm left with. So I have 8x plus 7, distribute the ax minus a, because that's 1 times a, plus bx plus 2b. All right, so my x's, so my 8x has to equal ax plus bx, and my 7 has to equal negative a plus 2b. Okay, so for my x's, we could get rid of the x's, so that's 8 has to equal a plus b. And I'm going to keep the bottom one the same. 7 is equal to negative a plus 2b. So this is nice because I could just add these together. My a's cancel. So it's 15 is equal to 3b. B is equal to 5. And then I'm going to take that and plug it into 8 equals a plus b. B is 5. 8 is equal to a plus 5. So a is equal to 3. So let's just write your final answer. A is 3, so it's 3 over x plus 2, plus b, which is 5, over x minus 1. All right, so let's take a look at 3. Okay, so for 3a, we have these linear repeats here. I have 2 of the same factors. So I'm going to have an x plus 2, and then I need the repeat. So plus x plus 2 squared. All right, so I need the A, the B, and this one will get a C. Okay. Okay, so we need to multiply this denominator by the x plus 2 squared. So over here I need x plus 2 squared. So I'm going to write it as the trinomial, which is x squared plus 4x plus 4. And this denominator needs an x plus 2 and an x. So I need an x and an x plus 2. So that's x squared plus 2x. And then the last one here is just going to need an x. All right, so I'm going to have here, okay, so I'm going to have 7x squared plus 27x plus 16 equals, I'm going to distribute the a. So I get ax squared plus 4ax plus 4a plus bx squared plus 2bx plus cx. Okay, so let's see. So 7x squared is going to equal to ax squared plus bx squared. My 27x is going to equal to 4ax plus 2bx plus cx. Sorry. And then I have 16 here, sorry, cross that out, is equal to 4a. So I can solve for a here. A is equal to 4. All right, so up here in the blue, I have 7 is equal to a plus b. So I could get my b right now because 7 is equal to 4 plus b. So b is equal to 3. And then right here, I know that 27 has to equal 4a plus 2b plus c. So 27 is equal to 4 times 4 plus 2 times 3 plus c. So this is 27 is equal to 16 plus 6 here, which is 22. Plus c, minus 22 from both sides, we get c is equal to 5. And then the last thing you have to do is to write the partial fractions. So we have a over x, that's 4 over x. B over x plus 2, so that's 3 over x plus 2. And c, which is 5 over x plus 2 squared. Okay, so let's take a look at 3b. So for 3b, I have here my fractions are going to be a over x, b over x squared, and c over x minus 1. Okay, so I need to multiply the first fraction by an x and an x minus 1. So that's going to be x squared minus x. And then the middle fraction, I need to just multiply x minus 1. And the last one, I need an x squared. Okay, so I have all the denominators the same here. So I have 7 x squared minus 2x minus 2 is going to equal to squared minus ax plus bx minus b plus cx squared. So then we're going to have 7x squared is equal to ax squared plus cx squared. Negative 2x is equal to negative ax plus bx. And we have negative 2 is equal to negative b. Okay, so I could solve this here. So positive b is equal to positive 2. All right, this here, actually, let me go with this one here, because that one has the b in it. So negative 2 is equal to negative a plus b. So b is 2, so negative 2 equals negative a plus 2. Minus 2, we get negative 4 equals negative a, so a is equal to positive 4. And then up here we have 7 is equal to a plus c. So then I have 7 equals 4 plus c. So c is equal to 3. And then your partial fractions would be a over x, that's 4 over x. B, which is 2. So that's going to be plus 2 over x squared, plus c, which is 3 over x minus 1. And that would be your answer. Okay, so let's take a look at number 4. Number 4 is to find the area using, given the vertices here. All right, so the first thing, remember I said you have to write down the formula. So I want you to write down a equals plus minus 1/2 the determinant. All right, and then you're going to write down a equals 1/2. Now you're going to set up, show me what you're plugging into your calculator, the determinant. So remember, going across is going to be... Okay, so you're going to plug in your points. So it's negative 2, 2. The last number is going to be a 1. Then it's 1, 3, 1. And then 3, 0, 1. Your last column is always a 1. So you're going to plug this into your calculator, into your matrix A. All right, so it's going to be a 3 by 3 matrix. Plug in this here, and you're going to get the determinant. So remember, the determinant is the DET in math. All right, so you need to get that number. So that out to be negative 11. So we're going to write a equals negative 1/2 of negative 11. So the area is equal to positive 5.5. Okay, so let's take a look at 4b. So I want to find the area of the triangle from these vertices here. So I start off by writing a equals plus minus 1/2 the determinant. So I'm going to set up the determinant. It's plus minus 1/2, 3, 8, 1, negative 4, 2, 1, 5, 1, 1. Okay, so plug this into your matrix, the 3 by 3 matrix, to get the determinant. So my determinant comes out to be positive, so it's going to be 1/2 of 61. So half of 61 would be 30.5. Okay, so I put the rest of the review on the next link, okay?